I'm doing a little personal project and thought I'd bring you along for the ride. You see, I've been doing an experiment with PIV. That is an acronym clash the electronics word because in electronics it means peak inverse voltage for semiconductor devices. But in the construction industry it means positive input ventilation. Let me show you what I mean by that. With positive input ventilation, if your house is a musty old house like mine is, then you can put a fan into the attic with a filter, and when the fan runs, it pulls air under the eaves, filters it, and then it pushes it down into the house. And in doing so, it's the equivalent of having a window open in your house. It just creates a positive pressure inside, and the air then escapes out around, say, door and window frames. And I've got a system. You get commercial systems. I bought one and it's massive. So I thought, just experimentally to see if I like this first before cutting a huge hole in the ceiling, I shall use a standard computer fan. Well, I say a standard computer fan. I'm using an Arctic P12 pressure optimized 120mm fan. I have to say, so far, I like it a lot because it just makes the place feel fresh and clean. So the filter I'm using, this was featured in another video. I made an adapter for this fan that takes a standard HEPA filter, and that is what's filtering the air to get fiberglass and dust from the attic and stuff out. But one thing I would like to do is I'd like to make it remote control so that without going up to the attic to unplug it, I can just basically push a button and turn the fan on or off at will, because at certain times in the evening when it's been thundering with rain, the whole area around here tends to get very humid. There is a point you don't want to bring in too much humid air. So I'm going to use one of these little 12 volt units, because at the moment this fan is running from 12 volts. It's running from a standard power supply with a little adapter here, so that when it's plugged in, it starts blowing and moving that air. But I fancy putting this module in. I've featured these universal modules. They're super cheap. I've featured them on a previous video. They're very adaptable. You can have them so it only operates when the button's pressed. You can have it toggle on, toggle off. You can have two buttons on and off, or you can have it so it has a short time delay, which is useless because really it's 5, 10, 15 and 20 seconds. You'd think it'd be quite useful making bigger delays. But anyway, this has 5 terminals. Let me zoom down a bit. It has the negative, the positive, and then it's got volt-free contacts in the relay. It's got the common in the middle, and then it's got the normally closed and normally open. Now, if I draw those on here, here are the contacts. So we have the negative, the positive, we've got the common in here, and we've got the normally open, and we've got the normally closed. I'm thinking of making it the normally closed because most of the time this fan's going to be on, it may be turned off overnight. So I want it to default so the relay is actually on when the fan's off. And that also means that by default, if there's a power failure, it's going to actually come on again automatically. So what I'm going to do is the supply, I'm going to bring it into negative, but I'm also, I'll put a wee arrow in like that. I'm going to take that to the fan. Then I'm going to take the positive in, and I'm going to loop it up to the common, and then the normally closed is coming out to the fan. So that, fan. So that when I push the button, I'll be able to toggle the fan on and off. And the fan is basically, it's a bungalow, so I'm going to put the switch where it's visible so you can actually see the fan going on and off. I do fancy making it light up though, just because I can. So let's start the project. I shall get my wire strippers here. And I'm going to do something controversial. I want your opinion on this. Because there is this folklore, well, it's not folklore, it applies to specific applications, that I'm going to put a touch of solder in these just to rigidify the ends up when I put them in. I hope this isn't copper coated aluminium. That'd be annoying. We want pure copper. But I'm going to twist the wires together, put a touch of solder on just to bind them together, because these terminals are very short, as they often are in these little products. And there is a sort of thing that, you know, you're not supposed to tin wires like that in that situation because it makes them more susceptible to breaking. But in this instance, there's no real vibration or stress because the remote is going to be mounted away from the unit. So here is the connector it's going to be coming in. So this is going to be the supply in. So I want the two black connections twisted together. This is where I find out if it is copper-coated diamond. They are twisting together and not unraveling. So that's pretty good. That does suggest they are copper. No guarantee, but you never know. The theory is, and it's true, that if you tin the ends of wires before putting them into terminals, it does make them more brittle. It means a lot of the strain with movement is all concentrated in one area instead of being able to flex over a large area. It causes it to concentrate in the area where the solder stops, and that can cause stress on the wire. It's a real thing. I just feel I need to mention it because otherwise people will complain. So the two negatives are connected together. Let's stuff them in right now. Let's stuff them in to that terminal and tighten it up, making sure that they are going in fully and not sticking out too much. No George Michaels, no careless whiskers. This is absolutely the wrong screwdriver for this. Have I got an alternative one for this? Hold on. This one may work better. Feels a bit better. It's not skipping like the other one was. And here is the incoming positive supply with a little loop to go up to the common connection on the relay. So I shall put that in here. These modules are really clever. They're really nice. They're very versatile, very easy to program too, and they just seem to be compatible with just about every one of these 433 megahertz or the frequency of your choice receivers. You get them in multiple different frequencies. I ended up with loads of 433 megahertz ones. I really should check if that's a legal frequency in the UK. I think it is. That's the problem of international purchases. You can operate on undesirable frequencies. I do remember the radio hams being quite miffed about that. That is possibly one of their things. Now, this one I'm not going to tin, but I am going to fold it over. That is also controversial. It just seems no matter what you do, people don't like it. They make up excuses for it being bad. I tend to fold wires and fill up terminals just because I don't want the wire sliding to the side. But according to various organisations of office workers who sit at a desk and make up rules for technical people, that's a bad thing. This though, this is a very thin wire. Not so keen in this one. This one is not twisting that well. I think this is copper-coated diamond. How annoying. Right, okay, tell you what, I'll put a blob of solder in this one. Thicken it up a little bit. I'm tempted just to fold it over and stuff it in, but I don't like the feel of that. Damn it, I wish they wouldn't use that material. I wish they wouldn't do copper-coated aluminium or steel or whatever they're using. It's not that critical in this application because it's low voltage and low current, but it's just annoying. It's not a good material. It's not a good choice. But unfortunately, because people have speculated in the price of copper, it's a thing that the copper is now so expensive that it's causing problems with people just not using it. And it is really the material of choice for electrical connections. The finance industry and the speculators and other people associated with that are responsible for a lot of bad things, really. Not many of them technical people. Like the people that make up the regulations. That's me having a rant, by the way. Here is the... here's the fan. Let's plug it in and see if this works, because I've done it. I'll zoom back out again at this point in time. Zoom. And I shall plug this in here, and then we'll find out if I've done everything correctly. So the fan is starting up by default. I've not programmed... turn this out. Actually, I'll unplug that at the moment. I've not programmed this unit yet, so it's not going to respond to me clicking the button. So this, to put it in toggle mode, you have to press this button twice. And then the LED lights up there. Don't know if you can see that. And then you press the button, and it's now programmed. Toggle, toggle. So now, I can turn the fan off when I don't want it running. And then turn it on remotely from downstairs. Might even stick this to the wall, probably won't. I'll just leave it lying. But that is it. Very useful little things. I like the fact that when they first introduced these modules, I've made a video specifically about this model, about how to program it. When they first introduced them, it was a universal case they used that just didn't work. The ports of the cables didn't line up, but now they've got one that it lines up, which is nice. So you can pretty much put this in and the wires should line up. This is where it doesn't line up with the holes. There they go, that's not bad. And also I noticed that they've got one here for putting the antenna out if you want it, but I'll leave the antenna in there and test it and see how it goes. But that's it. That is the project complete. We now have our positive input ventilation system that can be now controlled conveniently without having to go up into the attic and turn it on and off there. So that is a win. I'm going to go and put this in now.